Okay, so an airplane is flying at a horizontal circle at a speed of 104 meters per second. An 85-kilogram pilot does not want the centripetal acceleration to exceed 6.35 times free fall acceleration. Find the minimum radius of the plane's path. So we're going to draw a free body diagram, and the plane has got mass, so therefore the Earth is pulling on the plane with a force equal to its weight. And also we have a force that is being pushed on by the wings, or the air is pushing on the wings, and that is lift. And that's pushing the plane up. That's how planes can maintain their altitude. So we have this lifting force, and I'm going to call that FL. Okay? And then the plane is turning in a horizontal circle, so it's kind of flying around at the same altitude, right? And in order to do that, we know that we must have a centripetal force. There must be a force making the plane fly in that horizontal circle. Otherwise, it's going to, because of Newton's laws, because of the nature of the universe, objects tend to travel in a straight line, right? At the same speed forever until a net force acts on them. So this net force we're going to call Fx. Okay? So we're given that the velocity of the plane, the tangential velocity, is 104 meters per second. We know that g is given at 9.81 meters per second squared this time. The mass of the plane is 85 kilograms, and the acceleration of the plane needs to be 6.35 times g. The unknown, we want to know what is the minimum radius, and we also want to know what the force is that's exerted on the pilot. So we know that the centripetal acceleration for a given velocity and radius of turn is vt squared divided by r. So we can rearrange this, and we know that r has got to equal vt squared divided by the centripetal acceleration. R min is going to be equal to 104 meters per second squared divided by 6.35 times our acceleration due to gravity, which is 9.81 meters per second squared. So R min is equal to 173.63 meters. The next question, it says, what is the force that needs to be exerted on the pilot by this friction and the seatbelt and so forth to hold the pilot into place? The pilot has a mass of 85 kilograms, and so the force is just equal to m times a c. Mass times the acceleration. In this case, it's centripetal acceleration. That is 85 kilograms times 6.35 times 9.81 meters per second squared. And if we substitute that, we find out that the force exerted on the pilot is 5,294.95 newtons. When they talk about how many G's are exerted, this is what they're talking about. This pilot is turning in this loop, and he's experiencing 6.35 G's. That means he's going to weigh, or he's going to feel like he weighs 6.35 times as much as he actually normally weighs when he's just standing on the ground, which is a considerable force.